The last slide at the bottom of page 1 is reflexive property of equality. And now we're at the top of page 2. Here we go. The next one's going to be called the symmetric property of equality. Symmetric property, I'm going to abbreviate, of equality. Symmetric property of equality. Go write that down. We're on the top of page 2 now. Symmetric property of equality. And notice what this one says. Say again? No, now you're going to go on the top of page 2, the second one I gave you. Exactly. Right, Chang? Top of page 2? Rivetta, you with me? Top of page 2 now. The previous one was on the bottom of the first page from yesterday. This is the top of page 2.
You had this, right?
Yeah, remember yesterday we did 5?
Yeah.
The one we just did is at the bottom now. Now the one I'm doing now is on top of page 2 that I just passed out. That makes sense? Here we go. If, watch, look at the way it says. If A is equal to B, look at how ridiculously obvious this is. Then B is equal to A. Wow, that's pretty deep. A lot of these are so obvious, they're just logical rules of thinking.
Actually, that's what reflected.
Right, it's very related. This was saying is just two items, you can swap the left and the right. Because logically, if something's equal to something else, it doesn't matter which one's on which side. You can't deny this. Sorry. I just got pencils right now. They're right there. I don't know. Go ahead, keep annoying me. Try it one more time. Just don't make it like perfectly sharp. Just do what you can. My bad. Sorry. Try it one more time. Franco's got one for you to use. Oh, there. Thank you. Thank you. All right. That's pretty easy. Let's rock and roll. Actually no, almost last one. The next one's called the transitive property of equality. Transitive property of equality says, here we go. Let's write this down. Let me put this down here. All right, transitive property says this. Transitive property, I'm going to abbreviate, of equality. Says say again? For the phone call? It's cost you a stamp. Go for it. We'll go over here though. Transitive property equality says this. If, I'll do it in blue. I'll keep it blue. You'll see the logic of this. If A is equal to B and B is equal to C, nice. It's like a chain argument. Look at it. If A is equal to B and B is equal to C, one more time, Toscano, then what? Nice. Or we'll put A first since it's mentioned first. Then A is equal to C. Look at the logic there. It's like a chain.
Is it the same as the gizmo equaling and integral operator?
Well, it is the same, and the reason why we're able to say that the gizmo is equal to the puppy is because of this, the transitive property. We were just unaware that we're actually using a law of logic. See, we're involved in deduction, and we're, unbeknownst to us, unwittingly, we're actually using this law. Now you know that you're using that law when we concluded that gizmo equals a puppy.
What is it? We have to tell what the law is.
What? Yes. That's the whole point right now. So think of the warm-up. You gave me an argument for warm-up of why. It's going to give me a headache right now. You gave me an argument for why x equals, what was it? X equals 2, huh? And look at, here's the reasons why. Okay? What I'm going to do now is we're going to get into an example now. So you have your law books. Either on the back or on a separate sheet of paper. Let's get into example. How many did we do yesterday? We're going to get an example 2 now. Okay, so on the back of one of these papers, your choice, or on a separate sheet of paper, we're going to do example 2. Because this is really a continuation of yesterday's notes. We did 2, so here's example 3. My bad. Here's example 3. Given, ready? X equals 3, prove 3 is equal to x. Yeah, you always start off with your given. Very nice. Always. Very nice. Okay. Let me get my statements and reasons gizmo out here. On your notes, just go ahead and put S and R. You can abbreviate on yours. I'm putting statements and reasons, but you can just put S and R in your notes. Chang, you're good? Sorry, let's go. Ready? You're tripping me out here. It's going to be okay. Ready? Here we go, Luis. Statement 1. What do we start off with, Toscano? Right, x equals 3. That's always you always start off with your given. Statement 2. Are we ready to prove what we need to prove? Yeah. I can say now 3 is equal to x. What gives me that right? Think of the judge in the courtroom asking you, what gives you the right, Toscano, to say that 3 is equal to x? Objection, Your Honor, that's not the right law. Someone help out Toscano. What gives us the right to say that 3 equals x? Look at your law book. Thank you. I'm going to abbreviate symmetric. Symmetric property of equality. Rocking and rolling. Martinez, we're good? Yeah. Come on, man. Stay with me. So far, so good. Nice. All right, all right. Example 4. You ready? Oops. I'll just put example 4 underneath, actually. Example 4. Given 2x plus 3 equals 20. Prove x equals 7. Let's see. Go ahead and write that down. So this is example 4. Right, Franco? Stay with me. Let me get my statements and reasons ready. Boom. Boom. Again, you could just put S and R on your notes. We're involved with deductive logic. going to write that down on your notes, statements and reasons. Okay. Statement 1, here we go. You always start off with your given. 2 times x plus 3 equals 20. What gives us the right to say that? How dare we say 2 times x plus 3 equals 20? What gives you the right to say that, Rivera? Tapia, what gives you the right to say that? How dare you? Martinez, what gives you the right to say that? How dare you? How dare you, Franco? What gives you the right to say that 2 times x plus 3 equals 20? One more time. Chang, how dare you? What gives you the right to say that? Your Honor, this man needs to be escorted out of the court of law. No, just kidding. Bailiff, come and get him. What gives me the right to say this? You're going to laugh when I put the reason. I think some of you are overthinking it. Thank you. It's given. Jeez, you guys are overthinking this. I just gave you. No, bailiff, sit him back down. He's okay. Statement 2. Sort of, kind of, this is why I put this up. So this one's not a law. This is just, we're going to do distributive property. Remember, like way back in the day, when the numbers outside parentheses, you could distribute? Yeah, you multiply the 2 times this and this, and look what happens. So it becomes 2x plus 6 equals 20. What gives us the right to say that? We'll just write distributive property. We didn't actually write it down on our law book on this paper, but I'm assuming you know that, distributive property. So if you don't know that, make sure you put a little star on your notes right now. That's distributive property. Distributive property. Remember, think of what deductive logic means. Let me go back to the definition of deductive logic real quick. Watch. Deductive reasoning uses facts, definitions, and accepted properties. We just use the distributive property, so we're okay. Laws and properties are good to go. Let's keep going. Now what? What's statement 3? Franco, stay with me. What would I do to both sides to get x by itself now? One more time. What'd you do to both sides? So Toscano subtracted 6 from both sides, and in his mind, what results from that? I'm going to write down statement 3, what results from subtracting 6. Look at. What gives me the right to say that? Toscano. How dare you say that? What gives you the right to say that? Your Honor, escort him out of the court. Thank you. Bring him back in. Subtraction. Property of equality. I'm just abbreviating here. One more time. Last but not least, what do I do now, Martinez, to get x alone? By? Nice. What results? Give me what results when I divide by both sides by 2. Hit it. What gives you the right? How dare you say that, Martinez? Nice. Division, property of equality. You guys are rocking and rolling. Rivera, you're stretching me out. You're not writing this down. Again, give me an ulcer here. Come on. What happened, Rivera? Or Toscano? You had a question or no? Oh. Last example. Last example. Given. Here we go. Last one. This is example 4, 5. Is it? Example 5. Given, here we go. Two x plus 3x minus 2 equals 18. So far, so good. Prove, watch this. Excuse me. Prove that 4 is equal to x. What the heck? Why is 4 mentioned first? That's kind of funky. Okay, let's keep going. Let me get my statements and reasons out. Watch this. Ouch. Good idea, Martinez. Great idea. Here we go. Here we go. Statement 1. Statement 1. Tapia, what should I write for statement 1? You got it. No worries. Franco's going to come to the rescue. Hit it, Franco. Never mind. Go ahead. Go ahead. Close. Relax. Go ahead. Go. Awesome. How dare you say that, Martinez? It gives you the right. Bailiff, take him out of this courtroom. Chang, what gives him the right? One more time. It's given. Thank you. What's proven is what we're going to do right now. We're going to prove that 4 equals x with some deductive logic. All right, watch this now. Statement 2. What should we do here? Think of junior high school. Combine like terms. Thank you. The thing is, when we combine like terms, there's no fancy schmancy reason that we actually put on our law books. There's a very simple reason. Watch, look at what we're going to do. 2x and 5x make how many x's? How many? Bailiff, take this guy out of here. 2x and 3x make how many x's? Thank you. Watch. Stay with me. 5x minus 2 is 18. Wait, from statement 1 to statement 2, what do? We just simplified. So I'm going to put, for reasons, simplify. There's no fancy schmancy reason. Just put simplify. We combine like terms. It's called simplifying. Put that for your reason. Statement 3. Toscano, rock and roll. Hit it. Nice. So what results from that? I'm adding 2 to both sides. So that's what gives you the right? How dare you say that? Bailiff, get him out of here. Thank you. I'm going to abbreviate. Addition, prop of equality. Tapia, what do I do to both sides now to get x by itself? Good try. This is already multiplication. What's the opposite of multiplication? Right, I'm going to divide both sides by what? Nice. So what results from that? Let's see. If I divide both sides by 5, what will result will be x equals, one more time. Well, look at. She said dividing both sides by 5. So 5 divided by 5 would be 1x. 20 divided by 5 is 4. Huh? What gives us the right to say that? Tapia, what gave you the right? How dare you say that? X equals 4. Thank you. Thank you. Excellent. Have we proved what we need to prove? No, we haven't. We have x equals 4. It says 4 equals x. Thank you. What gives you the right to switch it? How dare you say switch it? This guy's Toscano's on fire. 5. Watch this. Watch this. 4 equals x. One more time. What's the reason? Thank you. I'm going to abbreviate symmetric. Prop of equality, rocking and rolling. Look, we switched the equal sign. What was once on the left became on the right and vice versa. That's all that said. Notice what we have to prove is always your last line. 4 equals x, that's exactly what we proved. And every single statement was justified by a legitimate reason. Boy, I'm so excited for you guys. You guys are doing awesome. Toscano, give me one light.